Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we're going to be going over a couple of examples of conditional variance. Now before we get started, make sure to subscribe to the channel for notifications on more math tutorials. Alright, now let's take a look at this example. Our example says consider two random variables, x and y, with a joint PMF given by the table below, and we're being asked to find the variance of x given y equals 1, and to find the variance of 1 over x plus 1 given y is even. Now before we start to solve for conditional variance, let's review a few formulas. The first formula is for conditional variance itself, and you'll notice that the formula for conditional variance is made up of conditional expectation. We have the expectation of x squared given y minus the expectation of x given y squared. So at this point, let's review the formula for conditional expectation. It is the sum of each of the x's that we were given in the PMF times the conditional PMF of x given y. So going back to the conditional variance formula, we have the expectation of x squared given y. So we're going to need to square the x's in our conditional expectation formula. Then that's minus the expectation of x given y squared. So we'll need to square our entire conditional expectation formula. Lastly, we see that we have a conditional PMF in our conditional expectation formula, so let's go over that piece. The conditional PMF is going to equal the joint probability of x and y over the marginal probability of y. So in summary, to solve for conditional variance, we're first going to start by finding the conditional PMF. Then we'll take that and plug it into here and here to solve for our conditional expectations. And then we'll subtract these two pieces to solve for conditional variance. So that's the game plan. Now let's take a look at our first example. We're asked to find the variance of x given y equals 1, and the first step is to find our conditional PMF. Now keep in mind in this example, y is fixed at 1 and x is what's varying. So for our conditional PMF, we'll have x equals 0, x equals 1, and x equals 2. And for the joint probability that x equals 0 and y equals 1, we have 2 over 9. And for the marginal probability that y equals 1, we have 7 over 18. Then this simplifies down to 4 over 7. The joint probability that x equals 1 and y equals 1 is 1 over 6 over the marginal probability that y equals 1. Then this simplifies down to 3 over 7. Then the joint probability of x equals 2 and y equals 1 is 0 over the marginal probability that y equals 1. And this simplifies down to, of course, 0. So take note here that 4 over 7 plus 3 over 7 plus 0 just equals 7 over 7, which equals 1. So this is a valid PMF. If this did not equal 1, then this would be an invalid PMF and we could not move forward in this computation. So now that we found our valid conditional PMF, we can move on to find our conditional expectations. For the expectation of x squared given y equals 1, we have 0 squared times 4 over 7 plus 1 squared times 3 over 7 plus 2 squared times 0. We see that these two pieces just equal 0, so that leaves us with 3 over 7. Now for the expectation of x given y equals 1 squared, we have 0 times 4 over 7 plus 1 times 3 over 7 plus 2 times 0 squared. These two pieces equal 0, so that leaves us with 3 over 7 squared, which equals 9 over 49. Now we can subtract these two pieces to get our conditional variance. That is 3 over 7 minus 9 over 49, which equals 12 over 49. So that's our conditional variance. All right, now let's move on to our second example. We're asked to find the variance of 1 over x plus 1 given y is even, and of course the first thing that we'll do is find our conditional PMF. And here y is set at an even number, so we're looking at when y equals 0 and y equals 2, and x is varying, so we have x equals 0, x equals 1, and x equals 2. Now the joint probability that x equals 0 and y is even is 1 over 6 plus 1 over 36 and that's over the marginal probability that y is even. So that's 7 over 12 plus 1 over 36. This simplifies to 7 over 36 over 11 over 18, and this gives us 7 over 22. Now the joint probability that x equals 1 and y is an even number is 1 over 3 plus 0 over 11 over 18, and this will give us 6 over 11. And then the joint probability that x equals 2 and y is an even number is 1 over 12 plus 0 over 11 over 18. And this simplifies to 3 over 22. Again, we'll take note of the fact that 7 over 22 plus 6 over 11 plus 3 over 22 equals 22 over 22, which just equals 1. So this is a valid PMF. So now we'll take this conditional PMF and use it to solve for our conditional expectations. For the expectation of 1 over x plus 1 squared, given y is even, we have 1 over 0 plus 1 squared times 7 over 22 plus 1 over 1 plus 1 squared times 6 over 11 plus 1 over 2 plus 1 squared times 3 over 22. And when we simplify, we get 31 over 66. Then for the expectation of 1 over x plus 1, given y is even squared, we have 1 over 0 plus 1 times 7 over 22 plus 1 over 1 plus 1 times 6 over 11 plus 1 over 2 plus 1 times 3 over 22 squared. And this simplifies down to 49 over 121. Our last step is to subtract these two pieces to get our conditional variance. So that'll be 31 over 66 minus 49 over 121. And that'll give us 47 over 726. And there you have it. We have found our conditional variances. If this video was helpful for you, give it a thumbs up, drop a comment down below, and also subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.